Hi everyone. Today we're going to look at solving one and two-step equations. You saw one-step equations last year in 6th grade, but we're going to take it one step further this year and start applying rational number operations to that. And we're going to start looking at two-step equations and then what equations may have distributive property or multi-steps. So an equation is different than an expression. Equations have an equal sign. They are a mathematical statement that two expressions are equal to each other. So, for example, 2 plus 5 is equal to 7. Or saying 3 times x plus 2 is equal to 8. And a solution is a value that makes a value of a variable that makes the statement true. So it can't just be any number. So an example of that would be over here. On the left, what is the solution of 3x plus 2 equals 8. I want to know, what does that x value here have to be? And so of course you could try different numbers and see what happens. You could try 3 times 1 plus 2, see if that equals 8. Well, 3 times 1 is 3, plus 2 is 5, so that's not 8. We could try 3 times 2 plus 2, and that does equal 8. So the solution is 2. Or we could say x is equal to 2 here. It's the number that makes this equation true. Keep in mind your inverse or your opposite operations. The inverse of addition is subtraction. The inverse of subtraction is addition. So addition and subtraction are complete opposites of each other. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. So keep those in mind as we go through to solve our one-step equations. So we've got a lot of equations here. It looks like a lot of work, but a lot of these are pretty simple to solve. So let's look at A. We have t plus 9 is equal to 17. Well, to solve this, I see that there's addition next to my variable of t, so I want to get rid of that by subtracting. So we'll subtract 9 from both sides, and we get t is equal to 8. We can look at B. B, we have x minus 5.2 is equal to 12.3. There is subtraction here, a minus 5.2, so to get rid of subtraction, I'm going to add 5.2. And I'm going to add 5.2 to both sides of my equation. Now these cancel out. So if I have a positive 5 plus 2 and a negative 5 plus 2, it's 0. So then I'll add 12.3 plus 5.2, and I have a value of x is equal to 17.5. Or you could say the solution of this equation is 17.5. In example C, we have a fraction, and you're going to see the operations don't change because we have a fraction. Now, this looks different because now the number term is on the left of the variable, but that doesn't change. I see I have a negative 2.2 over 3, and I can get rid of a negative 2 over 3 by adding 2 over 3. So we can add 2 and 2/3 to both sides of the equation. And this is easy. Y is equal to 8 plus 2.2 over 3 is 8 and 2/3. For example D, we have an example with multiplication. We have 30 equals negative 0.5a. Now, just because the variable term is on the right side of the equation, that doesn't change anything. We're just going to use our inverse operations here. I'm going to divide through by negative 0.5. Now, of course, you can use your calculator for these, but some of these are pretty simple. But don't forget about your positive and negative sign rules. And so I have an example here, or an answer here of negative 60 is equal to a, which you would really just write as a is equal to negative 60. Example E, we have 2/3 times x is equal to 5. So again, we're just going to divide because I have multiplication here. 2/3 times x. We're just going to divide both sides by 2/3. And off to the side, I'll do that math here. 5/1 times 3/2. We get a value of x is equal to 15/2. You can leave that as an improper fraction, or you can convert it to a mixed number, 7.5. And finally, and actually let me draw some lines here just to differentiate. We have negative a over 3.5 is equal to 9.2. Notice again I'm keeping the negative sign in the numerator, but also realize here that we have a negative and a 3.5 to get rid of. Now we're dividing by that 3.5, so we want to multiply. But at the same time, we want to get rid of the negative. So let's multiply by negative 3.5. We'll multiply both sides by that. So 9.2 times negative 3.5. That gives us a value of a is equal to 32.2. All right, so I want you to pause the video here, and I want you to go ahead and try the your turn problems. You'll see they were pretty quick for us to get through these 6 up here. Let's see what you can do. Okay, let's try. So for A, you had 4.9 plus z is equal to negative 9. We want to get rid of this positive 4.9 by subtracting on both sides. You notice I'm drawing this line here. That's just to kind of differentiate my work up here from my final answer. So that gives us z is equal to negative 9 plus a negative 4.9 gives us negative 13.9. For B, we have r minus 17.1 is equal to negative 4.8. We want to get rid of the subtraction of negative 17.1 by adding 17.1 to both sides of our equation. So that gives us r is equal to 12.3. For C, negative 2/5 plus y is equal to 6. We get rid of the negative 2/5 by adding 2/5 to both sides. So y is equal to 6 2/5. D, 3/5 C is equal to 36. This is multiplication, the 3/5 times c, so we'll divide both sides by 3/5. That is 36/1 times 5/3. And look, we have something we can simplify. The 3 and the 36. So that gives us a value of c is equal to 60. And finally, if we can fit it in here, negative a divided by 2.5 is equal to 3.2. We will multiply both sides by negative 2.5 to not only get rid of the negative sign here, but also get rid of the dividing by 2.5. And we get an answer of negative 8. Okay. So there's only one step to do on most of these unless you have a fraction, in which case you may have to do just a little extra work. But overall, they're pretty simple. Okay, let's move on. Let's take a look at two-step equations. to solve a multi-step equation, we must first isolate the term that contains the variable. That means we just want to get it by itself. And then we can start doing all our other inverse operations. So let's look at example 2a. 2n plus 5 is equal to 13. Now when I do multi-step equations, I usually like to just draw this line here so that I can see that I have two sides of my equation, so I can remember that I'm doing two operations here. So the first thing I'm going to do is get rid of this plus 5, because I want to get rid of the term that's next to the variable. I want the variable term to be by itself so I can just deal with that. So subtract 5 on both sides. That leaves me with 2n is equal to 13 minus 5 is 8. And now I can divide by 2 and get an answer of n is equal to 4. For b, 19 is equal to negative 3p minus 8. I'm going to just draw this line all the way down. And we want to get rid of the number terms first here. So minus 8 we can do by adding 8 to both sides. Think of this vertical line as kind of a mirror. If you have a plus 8 over here, you should have a plus 8 over on the right. That gives us 27 is equal to negative 3p. And now we can divide through by negative 3 to get p by itself. And p is equal to negative 9. And then finally c, 3 is equal to u divided by 6 minus 12. We want to add 12 to both sides. That gives us u divided by 6 is equal to 15, or 15 is equal to u divided by 6. Something divided by 6 is going to be equal to 15 here. So we'll just multiply both sides by 6. And we get an answer here of u is equal to 90. Pause the video here and try the Your Turn 2 problems. Okay, I'm just gonna clean up my space here. I have a little bit more room to write. All right, so let's look at the Your Turn 2 problems. For A, we have 9c plus 3 is equal to 39. Draw your mirror. Isolate the variable by subtracting 3 on both sides. That gives you 9c is equal to 36. Divide both sides by 9, and we get an answer of c is equal to 4. For b, you had negative 34 equals negative 4m minus 6. Remember that it does not matter that the variable term is on the right-hand side. You're still going to solve it as we normally would. We can add 6 to both sides to get that negative 4 by itself. Be very careful here when you're adding your integers. Negative 4 plus 6 is not negative 40. It's negative 28 is equal to negative 4m. Divide both sides by negative 4. We have an answer of m is equal to positive 7. And finally, 5 is equal to z divided by 6 minus 7. Add 7 to both sides to get rid of the number term. Gives us 12 is equal to z divided by 6. Because we have division here, we'll multiply both sides by 6. And so 6 times 12, I always forget this one, is 72 is equal to z, or z equals 72. Can you solve this? 6 plus b divided by negative 5 is equal to 21. Draw your vertical line to distinguish both sides of the equation. Subtract 6 from both sides. That gives you b divided by negative 5 is equal to 15. To get rid of the division of negative 5, we'll multiply both sides by negative 5. And so b is equal to negative 75. Finally, let's look at what happens when we have the distributive property involved. This would be an example of a multi-step equation, because really, there's about 3 steps here that we have to do. We'll distribute, we'll isolate the variable, and then we'll use an inverse operation to finalize that isolation of that variable. So let's start by using the distributive property here. 2 times 3x, that gives us 6x, and then 2 times 5 plus 10 is equal to 34. Now we have something that's pretty familiar, a 2-step equation. So draw your line. Subtract 10 from both sides. That leaves you with 6x is equal to 24. And then divide both sides by 6. X is equal to 4. Now I really stress drawing this vertical line and this horizontal line here just to help you organize and keep your work clean. What it also does is that this vertical line here helps you to see that if you do something over here, if we subtract 10 on the left, I have to subtract 10 on the right. That's what makes it an equation. It's not equal if I take something away on one side and I don't take it away on the other side. So we want to make sure that our equations are balanced. It's kind of like if you're on a seesaw at a park. If someone gets off of it, you fly up into the air. It's not balanced. So you need that balanced so that you are on equal footing there. So pause real quick and try your turn 3. Okay, let's go over the your turn 3. Distributive property first. 3 times x is 3x. Minus 3 times 4 is 12. Equals 18. Draw your line. Isolate the variable by getting rid of the number first. Plus 12, plus 12. That leaves us with 3x is equal to 30. Divide both sides by 3. And we see that x is equal to 10. You'll need to finish the summary down here, fill in those blanks just like you did last time, and we will go over that in class tomorrow.